Hi everybody, this is Enrique. Well, today we're doing some Microsoft Excel. And what we're going to be doing is plotting a graph of planetary data. Specifically, we'll be calculating the orbital acceleration, just like the example we did in class. Awesomeness. Okay, so according to this sheet that you have, your handout, you are supposed to go to the NASA website and find some planetary data. So, planetary data, NASA. This is probably good enough to Google. There it is. It's the first one. Clicko. So this is the data we're going to be using for the planets. Data was acquired by Johannes Kepler and Tycho Brahe, as sort of explained in class, hopefully. Anyway, we have a lot of planetary data. Let's start plotting stuff and see what happens. Of course, we want to calculate circular acceleration. So you're going to have to open up Microsoft Excel, go to your Student Applications folder, Microsoft Office folder, and then find Microsoft Excel. High five. So you want to open up a spreadsheet. Spreadsheets are pretty badass. They were invented as visible calculators back in the 80s, and revolutionized many industries. Okay, so here's what your spreadsheet looks like. Basically, how this thing works is you can manipulate numbers in here. That's what we're going to be doing. So first thing we have to do is start typing in our planet name and radius. So planet name. I just typed that in. So I know this sounds crazy. I'm going to make this half the size so I don't have to use a bunch of windows. So let's see. Make this a little smaller. There we go. Now, because I've made them half the size, I can just type in, here's my planet names over here. Mercury. Venus. Ooh, I can't spell. Mercury. Venus. Earth. Is the moon a planet? The moon is not a planet. Do not include the moon. So just skip to Mars. Jupiter. Saturn. Uranus. Neptune. Pluto. Is Pluto a planet? No, but we're gonna include it anyway, because we love Pluto. We're gonna need 2 bits of data, as was explained in our pre-lab. They are radius and orbital period. Okay, if you're coming over here, which one of these is radius? Well, there's 2 of them. Distance from sun and diameter. Which one should I use? Turns out you want to use distance from sun, because distance from sun is essentially your radius. If you have a planet orbiting the sun, it moves in approximately a circle of radius distance from the sun. So we're going to copy these numbers here into our Excel spreadsheet. We're just going to copy them in. So just type them in. 57.9, 108.2, 149.6. This is the moon. We're going to ignore the moon number. 227.9, 778.6, 1433.5, 2872. La la la. Sometimes you just have to sing songs when you do it. What else can I do? Orbital period! That one's easy. It's right here. Exactly what it looks like. Orbital period. So this is how many days it takes for one spin of the planet. 88 for Mercury. Venus has 224.7. Earth takes 365.2 days to do one rotation. We call that 1 year. Haha. So Mercury's orbital period is 88 days. in 88 days, Mercury has 1 year. A Martian year is 687 days. 4331, 10747, 3589, 59800, 9560. Cool. So we're basically done copying data. Now we're going to manipulate it. That's what Excel is good at. Excel is good at copying data. Alright, so step number... I'm on number 8 in my handout or whatever. It says, create some new columns. Call them radius in meters. Hey, here's a trick. Double-click on the columns to make them the size of the name. Radius in meters. So double-click right here. That'll make it that big. Orbital period in seconds. I'll just say period in seconds. Like that. So how do we convert these days to seconds? Well, we did this as an example. So 88 days. 88 days. So you're going to... Ooh. What am I doing? I'm just doing it without talking. So when you're going to manipulate numbers, you need to do an equation. And equations start with the equal sign. So you're going to go into the cell and type in equal sign. Now, you're telling basically the spreadsheet, I'm going to do some data manipulation. So what you're going to do is come over here and click on this. 88 days. You don't type in the number 88. You type in, you click in the cell. C2. C2. That's my cell. What do I want to do with that number? I want to multiply that number by 24 hours in a day times 60 minutes in an hour times 60 seconds in a minute. That will give me the number of seconds in 88 days. High five. You should have, if you executed this properly, equal sign C2, this 88 day thing, times 24 times 60 times 60. You'll get a number like 7,600,000, blah, blah, blah. If I did this correctly, I can copy and paste down. Now, there's a trick in Excel. See this little box in the lower right-hand corner? See this cell is selected. It's in green right here. In the bottom right-hand corner, there's a little box right here. This is a copy down box. If I click there, I can copy down. I just copied down, and what I've done here is every single one of these is basically doing the same operation times 24 times 60 times 60 times whatever cell is below it. Isn't that nice? So all of these are done. I just calculated the period in seconds for everything. Awesome. How do I get these to meters? Well, if I look over at this table, distance from sun, 10 to the 6th kilometers. So what I'm going to have to do is times by 10 to the 6th to get kilometers. But if I want meters, I want to times it by 1,000 times 10 to the 6th. So here's what you do. Equal sign, because I'm manipulating numbers. Click on your radius. That's your B2 number. Times 10 to the 6th. That'll get me the kilometers. To the 6th, I can do this little caret symbol. The caret symbol is shift 6. Like if you look at the number 6 on your keyboard, you can do a little shift to get that little caret thing on there. Okay, multiplication is shift 8. Or if you have a multiplication button like my keyboard does, it's nice. So B times 10 to the 6th, that's going to get me kilometers, but I need to multiply it by 1,000 to get it in meters. High five. So my number's big. All copied down so you can see the numbers. Check your numbers. Make sure they're all high five. So basically, I've done my first manipulation. I've converted my radius and period to meters and seconds instead of days and kilometers. It's all in metric. Metric is good. So maybe type in here, metric is good, because metric numbers work in the equations. That's how the equations are built. All based on metric units. Okay, the next new columns I need to do are basically circumference. Let's do circumference. Circumference. Okay, this is going to be in meters. What's the circumference equation? Well, it's 2 pi times the radius. 2 times pi. What's pi? Well, you can just type it in. 3.1415926 or whatever. That's fine. I don't really care. Type in pi. That's a lot easier than some other ways. Alright, you can also, in Excel, you can type in the word pi, but then you got to open and close parentheses like that. That will also work. But, you know, if this is a little too confusing for you because it's got some weird notation like these parentheses, like if I don't have both parentheses in there, it's not going to work. So just be aware that, like, you have to be pretty precise when you're calling a function like pi. But this is more precise. So you're going to multiply 2 pi times the radius. Which one is the radius? Is it this one or this one? I'll be honest, you guys. It's this one. This is the one that you want because it's in meters. And metric is good. You don't want to use the crap units. You want to use the metric units. High five. So this is my circumference in meters. Let's copy this down. Whoop. All done. I've got how much each planet has moved around in one spin. Well, what's the speed of something? Let's call it velocity. Velocity. It's called orbital velocity on your handout. High five. So this is going to be in meters per second, by the way. So, double click on this. Meters per second equal sign the distance you travel. Notice I'm not typing in any numbers. So, equal sign. And then come over here and click this. That's my distance divided by the time. Which time? 88 or seconds? Seconds, because metric is good. Metric is good. So here's my meters per second. Wow. Mercury's going at 47 kilometers per second. Contrasted to Pluto, which is only going about 4 kilometers per second. So Mercury's zooming around. That's awesome. Acceleration. Acceleration. Let's call it, what do I call it? Orbital acceleration? Orbital. This is my centripetal acceleration in meters per second squared, right? So, high five. I don't need this data anymore, so I'm going to maximize my Excel window. High five. What's the acceleration of my planet? Equal sign, velocity squared. How do I square something? Well, you could just times it by itself like that. That would work. You could also put a little caret symbol like we did before, which is an exponent squared, divided by my radius. Radius is going to be this number here. Metric is good, not that one. High five. All she done. Copy down. Blacko. So there we go. There's my orbital acceleration. Okay? High five. Now we're going to do 2 additional columns because of graphing later. Graphing later is going to be... we can graph now, but I'm going to graph... I'm just going to make these columns because they're going to be good for later. We're going to take the log of the radius, and we'll take the log of acceleration. So let's make these big. What's a log function? It's, you know, the logarithm function. Useful for lots of reasons. So to do a log function, we have to call a function just like we called pi earlier. Pi is actually a function wherever it was. Let's hit escape. If you ever get stuck in a cell like that, just hit escape. So over here somewhere we use the pi function right here. It has some parentheses, right? So we can, well, in order to do log function, it's the same thing. You have to use this log function. So you type in all caps, L-O-G. Caps are important. Oh, by the way, when I did the pi back here, make sure you do it in caps, capital letters. If this is confusing, just type in 3.14. But like, if it's not working, you can always go back and hack yourself 3.1415926 number. Anyway, all caps, log. You're going to open your parentheses. You're going to close your parentheses. What do I stick inside of these parentheses? I just clicked on this, by the way. What do I stick inside of there? The radius. Where's radius? Boom. Metric is good. High five. What do I stick in here? Oh, let's copy down. Copy down. Your numbers will look like that. Awesome. Equal sign. Log of acceleration is exactly what it looks like. Log of acceleration, this number. End parentheses. Boom. Ooh, negative 1.4. That looks good. All of these look good. High five. Okay. Now that we're done, we can graph. So what have we done here? We copied and pasted this data. Just pretend you got it from Kepler. You did some data manipulations. Time to make some graphs. Okay. The graphs I want are radius, versus acceleration. So here's what you do. You select the radius and you select the acceleration. How do I do that? Because every time I click on here and then try to click on that, it like resets. So here's what you do. Select one data. Now with your non-dominant finger, hold down the control button. Hold control down right now. This is selected already. Nothing, my right hand is not touching the mouse. You hold control button. And then now you just select this data, like that. So you use your dominant hand right to select, your right hand probably. Right hand clicks and selects this like normal. Hold control button down with your left hand. And then select this. High five. Do I want to select the titles or just the data? The correct answer is just the data. Excel doesn't understand text or string variables very easily, so please don't try to confuse the computer. Just type in the numbers, man. These are the numbers. Alright, you want to go up to Insert, Chart. It's over here. See the little one that looks like a graph? A scatter XY plot? That's what you want. Click on the scatter graph. High five. Looks like this. See how that looks like an exponential? High five. What can we do with these exponential graphs? We can log them. So believe it or not, you want log radius and log acceleration as your next graph. Oh, isn't that nice? They're right next to each other, so I can just select the data. I don't need to do the control trick or whatever. And you want to insert a nice little graph here for this one. Boom. High five. Oh my god, that looks like a straight line. So this is essentially what you want to do today. It says you got to do other stuff like add chart titles and stuff. People generally do not despair with this kind of step. You just type in like radius versus acceleration, right? And then how do I add the category labels? There's like these plus things. You can come over here and add stuff. So like anyway, people are pretty good at this kind of thing. So it's pretty easy. I'm not going to go into how to make a chart. I think you guys can do that. Really quick, here's something you can do. Make X's instead of circles. I'm always like kind of a Nazi about this kind of stuff. How do I make X's? So you just click on the circles. You can click on the circles. It'll select all the circles. Right click on it. I think it's Format Trend Data Series. Let's see if this works. Ooh, pops up over here. Look at this stuff over here. Paint bucket is what you want. Marker, they're called marker. So marker is the name of the shape of the things. So you can make circles or other marker types. Okay, marker options. I want to use a built-in. Do I want to use a circle? Let's use this. And why isn't it black? I don't know why it's not black. But whatever. Let's say I want blue. Blue, isn't that nice? You got like blue little X's. Bet you can change it to some sort of like color. Oh, here's the color. Let's make it black. Why wouldn't you want blacks? Anyway, there it is. Isn't that nice? So that's a really nice thing. What should I do with this if I ever have a nice looking line like this? Add trend line. Let's go to this little caret symbol. More options. And, oops. Yeah, this one right here with the little charts. Let's display the equation and the R-squared value. Okay, so this equation right here, y equals mx plus b. What's my slope? -2. Why is my slope -2? Because it's an inverse square law. This is y equals 1 over x squared. Y equals 1 over x squared on a log-log plot means it's an inverse square relationship. This is 1 over x squared right here. So this is 1 over x squared. Almost perfectly. Look at that. R squared equals 1. Isn't that insane? What is that saying? That's saying that the inverse square law is true. Because look at all this data that suggests as we go out here, I can make a prediction. 1 over the square of the radius is what the acceleration will be. Isn't that crazy? F equals ma. That's what your data is saying. Your data is saying you got pwned. That's basically what you're doing. Thank you for listening. It's time to you're doomed.